Hello everyone, in today's video I'm going to talk about remainder theorem and also factor theorem. So before continuing, you need to understand how to do long division and also synthetic division because we're going to use that in this video. So let's get into it. So what is factor theorem? So factor theorem states that if you have a function, let's not use a function. So if you have quadratic x squared plus ax plus c and divided by x minus k. If you want to find the value when you input x equals to k in the numerator, then f then our this when x equals to k is the same thing as our remainder. So for example, if we have x squared plus x plus 1 divided by x minus 2, right? You're going to find the value of the numerator. So when x equals to 2, then it's equals to 4 plus 2, right? Plus 1. That will be 6 plus 1, which is 7. If we use this, let's us use the long division. So x minus 2, x squared plus x plus 1. Remember, so this is x because x squared over x equals so x. And this will be x squared minus 2x and then minus 3x and then goes down, and then we have 3 plus 3 and 3x minus 2, sorry, 3x minus 6, and we minus them, we have 7, so plus 7 over x minus 2. So the remainder is 7. It's correct. So when x equals to 2, it's the same thing as we're finding the remainder, which is 7. And our remainder theorem, we can actually denote it as, let's say, we have the quadratic x squared plus bx plus c is equals to our d, our divisor, which is x minus 2, times our quotient. This is respect to x. So, and then plus by our remainder, which, as you can see, let's say if we have x squared plus x plus 1, x squared plus x plus 1 over x minus 2. It's just basically the same thing as x plus 3, right? X plus 3 plus 7 over x minus 2. Well, when we multiply it by x minus 2 on both sides, what do we get? This cancels, so we have x squared plus x plus 1 is equals to our quotient, our divisors first. So x minus 2 and x plus 3 plus by 7, just plus by 7 because x minus 2 and x minus 2 cancels out. So this is the same thing. Well, this is very useful for a lot of situations. Okay, let's do another example of the remainder theorem. Let's say find x, we have x squared plus 2x squared plus 7x plus 1. Okay, we need to find when x equals to say 3. Okay, when we input x equals to 3, we have 2 times 3 squared plus 7 times 3 plus 1. We have 2 times 9 plus 21 plus 1. And we have 18 plus 22. Then we have our 40. Okay, that's when x equals to 3. How about we use the remainder theorem? So when we, let's do synthetic now, synthetic division. We have our divisor, which is x minus 3. So 3, 2, 7, and 1. We add them. 2 goes down. 2 times 3 is 2 times 3 is 6. We add them, which is 13. And then 3 times 13 would be 39. At noon we have 40. So the remainder is 40. Well, that's a shortcut. So it's clearly faster if you use the remainder theorem when you use the synthetic division. Okay, let's do another example. What if we had like x cubed plus x squared plus 2x plus 1? Um, we have um, find when x equals to 3, 2. So when x equals to 2, we have 2 cubed plus 2 squared plus 4 plus 1, right? So 8 plus 4 plus 4 plus 1. We have 16 plus 1, which is 17. So let's use the remainder theorem. We have 2, 1, 1, 2, 1. We add them. We have 1, we have 2, 3, 6, 8, 16, and then yeah, this is 16, 6, and then we have 17. So that's our remainder. Okay, so they're both, yeah, it's the same. Okay, now let's move on to our factor theorem. Quadratic, right? Ax squared plus bx plus c, and we divided by x minus k, where it is a factor of ax squared plus bx plus c. So that means when we input our x equals to k, then our polynomial here, which is p, then p equals to 0. And that means what? Our remainder, when p is by our x minus k, is equals to 0. So let us um, have an example. Let's say we have a 2x squared, x squared plus 5x plus 6. uh, X equals to 3 is a factor. Then find the other factor. So I mean, we can use factorization. So it's just x plus 3 times x plus 2. But let's say we don't know the factor, and then we can use the factor theorem. So test if is actually true when x equals to negative 3, actually negative 3, this result equals to 0, then it is a factor of this polynomial. So x equals to negative 3, so negative 3 squared plus negative 3 times 5 plus 6. We have 9 plus 15, negative 15, and plus 6 would have, yeah, this is exactly 0. So what we have here, x minus 3, to find the other factor, 1, 5, and 6. Then we have what? 1, 5, negative 3, so it will be 2, and negative 6, and 0. So we have 1, 2, right? So yeah, the remainder is 0. So we have here, we have, so our x squared plus 5x plus 6 over x plus by 3 is equals to x plus by 2 times by x plus by 3 and add by 0. So this is our factorized form. Okay, another example would be this. Let me erase this. Let's say we have a cubic, x cubed plus 9x squared plus 26x plus 24. And let's say we know that one of its factors are x minus x plus 4. So when x equals to negative 4, uh, our polynomial tends to 0. Let's use the syntactic division. So we have x plus, we have negative 4, 1, 9, 26, and 24. So we add them. 1 goes down, negative 4. Well, we have 5. This will be negative 4, 5, and negative 20. We have 6 and negative 24. We have what? A 0. So using the form of the remainder theorem, we have our divisor times the quotient and plus by the remainder. So our quotient would be x squared plus 5x plus 6. Then our divisor is what? X plus 4 plus r of x, which is just 0. So we know that this is x squared plus 5 x plus 6 will be x plus 3 and then x plus 6. Okay, so that's our the factors. Well, to find the zeros of it, to find the zeros, we just set everything to 0. And we have x equals to negative 4, x equals to negative 3, and also x equals to negative, what's this? Supposed to be 2. X equals to negative 2. That's the zeros. When you input those numbers, our uh, polynomial here, a cubic, is 0. So that's it for today. That's for remainder theorem and factor theorem. So the next video will be questions for this unit. So thank you.